Good afternoon.
Good afternoon.
All right, how's everyone?
I think you've already seen it.
He asked how we are.
Good.
Good to hear. Anything exciting going on today? For anybody?
We got our state championship baseball rings today.
Wow. And you didn't have to steal them from another school. That's even better. That's awesome. So did you guys have like an assembly or something, or?
We were gonna do it at our football game tomorrow, but we have to wait until next week. So they just let us have it until then, and then we're gonna do
All
it.
right.
So,
Well, I'll tell you what. In honor of that, I'm going to tell you, after I take the roll, I'm going to tell you a baseball joke. Okay? And I'm kind of wearing like a baseball thing. Anyway. All right, let's go over the roll here first. Okay, Joran?
Here.
Let's see. Actually, I don't need to show that. Okay. Rachel?
Here.
Alana?
Here.
Nathan?
Not here.
Thank you. David?
Here.
Chloe?
Here.
Oh, David, I forgot to tell you. So somebody in my Holbrook calculus class said to say hi, and they told me to have you stand up and show us your dinosaur shirt. And I'm like, how do you know what shirt he's wearing? And he says, he always wears the coolest dinosaur shirts. So are you wearing a dinosaur shirt today, David?
I am not. I'm actually wearing a Spartan Race shirt.
Okay. Do you have a lot of dinosaur shirts?
I have some.
Okay. All right. Anyway, they're starting to get famous. So I just thought I'd let you know. So anyway.
Can I ask who asked?
That was Kobe Corporage in Holbrook.
Okay, thank you.
So do you remember Kobe from, I guess your 152 and 189 class, maybe? Anyway. All right, Chloe.
Here.
Aiden.
Here.
Junior.
Here.
Rhett.
Here.
Price. No Price. Denon.
Here.
All right. Skylar.
Here.
Hannah Whipple.
Here.
Brooke.
She dropped the class.
Oh, did she? Okay. Yeah, I wonder why anyway. Hopefully that'll be updated. And Joey
Here.
and Hannah Zent.
Here.
Okay. All right. So, my first question is, so did anyone have any problem accessing the Moodle, taking that first quiz? And some of you took it before class yesterday, so I just want to make sure that we're still good on that. Okay. Let's see here. Okay.
I like your shirt and hat, Mr. Strong.
Well, thank you. Oh, the baseball joke. Okay, so I told you about my funeral party, right? Okay. So anyway, so I was coming up with jokes about funerals and stuff. So here goes the joke: is that there are two buddies. They're kind of getting old. We'll call them Rhett and Denon. And so anyway, so they're getting kind of old, and one of them says, I just love baseball. Baseball is my life, and I can't imagine going to heaven without baseball. And so then the other one says, well, I'll tell you what, let's make a deal. Whichever one of us dies first, we'll come back and tell the other one if there's baseball in heaven. Deal? And so Den and Rhett make this deal. Well, so anyway, so as it turns out, Denon dies first. And Rhett's really missing him, and he's wondering, I wonder if he's really going to come back. Well, so then the next day, Denon's spirit comes back, and Rhett says, so Denon, is there baseball in heaven? And Denon says, well, I have some good news and some bad news. And Rhett says, well, what's the good news? And he says, Rhett, there is baseball in heaven. And Rhett's so excited and happy, and he says, well, that's awesome. What could be the bad news? And Dennis says, you're pitching on Saturday. All right, well, anyway, that's my joke. All right, well, let's go ahead and get busy here. So we are in section 1.2. So let's go there. And we were still working on graphing. This is still our review of pre-cal in this section. This whole chapter here. And we actually had talked a little bit about graphing and let's see, I need to share that. Okay, so we had talked a little bit about vertical and horizontal shifts. And so now we're going to be talking about what we call scaling. Okay, so making it, the way I taught this in 152 was like making graphs wider or narrower. That's kind of how the language we use in pre-cal. So this is saying if you multiply by a number bigger than 1 in front of the function, then that stretches the graph vertically. So basically it makes it taller or narrower. If you multiply by a fraction like 1/2 or whatever, then it will make the graph shorter or wider. If you multiply by a number inside the function, then it compresses the graph horizontally. So in other words, it compresses it this way, sideways. And then if you multiply by 1 by a fraction, then it stretches it horizontally. And then if c is -1, if you multiply by a negative in front of the function, it reflects the graph across the x-axis. And if you multiply by a negative inside the function, it reflects it across the y-axis. So, Rhett, did you like my baseball joke?
Yeah, I did.
All right. Feel free to share that with others. You don't have to credit me or anything, though. Most of my jokes, it's better that you don't credit me. Okay, so well, I'll give you another little minute. Okay, so the rest of the column on your guided notes is actually a repeat of what we did the last section. So I'm not going to go through that again. It's just if you wanted to have the reflections all on one page, you could copy that again from 1.1. So I'm going to go to the last column there for practice 4. Oh, actually, I want to show you this. I thought this example was pretty good. So as far as the reflections, so here if you have y equals the square root of x, okay, that's the square root function. So if you put a negative in front, it reflects it through the x-axis. If you put a negative inside the function, it reflects it through the y-axis. And then if you actually put a negative in both, then it reflects it twice, reflects it through both axes. And so you get this little green part, okay? So I like that example because it kind of helps clarify what's the negative doing in each one, how it affects the graph, okay? All right, so go ahead and do that one, practice 4. All right, so, all right, you remember your old friend, random wheel? Let's see how we're gonna do here. So, ret, perfect. All right, so tell us about the transformations on this graph. How is this graph gonna be different than just the regular parabola y equals x squared?
It reflects across the x-axis and it gets shorter or wider.
Okay, good. Now, and you do want, and if you didn't put it in your answer, put that it is a parabola. It might be obvious, but make sure that we know it's a parabola. It's reflected across the x-axis, and then you can say compressed vertically, or again in Math 152, I would just say it's wider. Okay, but either way, how you want to put it. Okay. Oops. All right, any questions on that one? Okay. Oops. So, formulas of transformation. Sometimes a formula can be written that describes the transformation. So in this case, you think of the given function as just like your x that you're going to then manipulate. All right, so let's say here's my function. F of x equals blah, blah, blah. Okay? And then it says find a formula to compress the graph horizontally by a factor of 2, followed by a reflection across the y-axis. Okay? So, to compress the graph horizontally by a factor of 2, then what we're going to do is replace the x with 2x inside the function. Then to reflect it across the y, then we put a negative with the 2x inside the function, because that's what reflects it across the y-axis. So everywhere there's an x in the function, I'm going to replace it with negative 2x. And basically that's it. You could leave it like that, or if you wanted to simplify, you could. But this is mainly what I'm looking at, is that we want a negative and a 2 with the x inside the function. Okay? All right, so let's have you try the practice here. All right, Aiden.
Well, you would just, instead of having the negative inside the parentheses, you would just switch the sign on that, and then you would have the 2.
So which signs do you switch?
So, like, negative x to the 4th plus 4x, like.
Yeah, so switch all of them. Okay?
Yeah.
So in other words, you either think of it as like the negative in front of the whole thing, or switch all of them, and then replace the x with 2x. Okay? Good. Any questions on that? All right. Well, great job, Aiden. Any other questions on anything here in 1.2? Okay, so that means, so now we finished another section. So that means next week we'll have a quiz on 1.1 and 1.2. Okay. Now again, each of these quizzes are going to be less than 15 minutes or whatever. So to have 2 within 1 hour slot is not going to be, I don't think, going to be arduous for anybody.
Yeah.
But you're going to let me know if it is. Okay, yes. Was there a question? Okay.
No, I have someone else try.
Okay. Okay, so 1.3, this is going to be the big review of trig. So, I'm not saying we're going to do all of Math 189 in one lesson, but a lot of it we are going to review. And what kind of my goal in making the guided notes for this section is to sort of have a resource page for you to be able to look up, like have all your formulas written, have the unit circle there, everything. Because believe it or not, there is not a place. The unit circle is not even in your calculus book. So the idea is to put all that information in this section of guided notes. So hopefully it will be a good resource to you. As a matter of fact, so my other calculus class, every time they ask me a question about trig or trig identity or whatever, I'll say, okay, get out your guided notes for 1.3 and let's look it up. And so it's really has become a good resource for us. So trigonometric functions. All right, so angles are measured in degrees or radians. Now, when in trigonometry, especially when you're doing an application problem, you're usually measuring in angles. In this class, the default is going to be radians. We're going to use radians most of the time. Most of the calculus formulas, it's assumed that you're in radians, okay? So I would say probably 90% of the time we're going to be in radians, okay? But just to remember what a radian is, it's the arc length, the distance of along the circle, that's the arc length, that has the same distance as a radius. And so that radius of the circle, that length along the circle is called a radian. All right, so some equivalent angles that we have. 0 degrees is 0 radians. 30 degrees is pi 6. And you can write it as pi 6 or 1/6 pi, whichever you feel more comfortable with. 45 degrees, pi fourths. 60 degrees is pi thirds. 90 degrees is pi halves. And then the one of these that you really need to memorize is that 180 degrees is pi radians. Because that's what we use for a conversion factor. Okay, so these are our two, this is kind of how we convert from degrees to radians, is that conversion factor, pi radians is 180 degrees. We multiply that conversion factor. Now, if we're starting with degrees and want to convert to radians, then you multiply by pi over 180. If we have radians and we want to convert to degrees, you multiply by 180 over pi, because you want the units to cancel. So the way that we do that, so let's say I want pi thirds radians and I'm converting that to degrees. So then I say, okay, so pi thirds radians times, and so since I want the radians to cancel, I multiply by the pi radians at the bottom, 180 degrees in the top. Then the pi radians cancel. 180 divided by 3 is 60, so 60 degrees would be my answer. All right, any questions? All right, so let's have you do, whoops. All right, so express, this is 270 degrees in radians. All right, Chloe, when you've got it.
3 pi over 2.
3 pi over 2. Excellent. All right, any questions? Now, if you do it in the calculator and you don't have it in terms of pi, then you could also write as 4.712 radians, excuse me. Okay. All right, any questions on that? All right, next, the arc length formula. So this is one of the formulas that we use in trig where the angle has to be measured in radians. So S equals R times theta, where S is the arc length and R is the radius. And theta has to be in radians. Okay? So the S, that's the part on the circle, the arc length. The R is the radius, and then the theta is the intercepted arc, this angle that gives us this arc in radians. So S equals R theta. So, it says if r is 5 inches and theta is pi thirds, and we want to find s, then you say, okay, so r is 5, theta is pi thirds, so s equals r theta. So we just do 5 times pi thirds. So it's just 5 pi thirds. Now the units for r and s are the same. So if the radius is given in inches, then the arc length is also in inches. Okay? Now, if the angle is not in radians, then you have to convert it to radians first. Okay? So in the practice problem, I give you the theta, so you have to convert that to radians first. Then plug it in. The thing that's a little tricky is I'm asking you to find r instead of s. Okay? So let's see if you can do that. All right, so Junior, when you've got it.
Five pi.
5 pi? All right, let's see what we get. Okay, I got 18 over pi. Okay, so let's go through this. So the first thing you have to do is convert the angle 20 degrees to radians. So you multiply by pi over 180. So that's going to give you pi ninths. Okay? Is everybody okay on the angle? So now you plug it in. So S equals R theta. So this time I'm giving you S is 2. And then the theta, we plug in the pi ninths. So to solve for R, you multiply each side by the reciprocal, 9 over pi. And so then you'll get R on the right. And then 9 times 2 is 18 over pi in feet. And so if you did that as a decimal, it would be 5.729. That's your answer. Truncated, or just cut off at 3 decimals. Or if you round it, that would be 5.730. So any of those would be, I would consider correct. All right. All right. Any questions on that? So Junior, if you don't mind my asking, what did you do wrong on that one?
I got the numbers mixed up.
Oh, okay. All right. So any questions? All right. So then when we're measuring angles, we have in trig, we put the vertex of the angle on the origin, and then the initial ray is on the positive x-axis. And then if we measure counterclockwise, that's going to be a positive angle. If we measure down clockwise, that's going to give us a negative angle. And so this is what we call standard position for the angle. Okay? All right, now, anytime we have an angle, we can get what's called a coterminal angle by just going around the circle all the way again. So to get a coterminal angle, you add or subtract 360 degrees or 2 pi radians. So here, if we take pi fourths, and then we go all around again and add another 2 pi, that's going to give us 9 fourths. Or here, if we take, this is pi, so if we go all the way around, that's 2 pi plus another pi, so that's 3 pi. Here we have negative 3 pi fourths because we're measuring down. And here we're measuring down all the way around, so that's negative 2 pi plus another negative pi halves. So that gives us negative 5 pi halves. So when we add or subtract 2 pi or 360 degrees, that gives us a coterminal angle. So it looks the same, it's just we've gone around one more time. We have one more extra revolution. All right, now the trig functions. The 6 trig functions are all based on ratios of the sides of a right triangle. So you imagine that you have an angle of a right triangle, and the leg next to it, the side next to it, we're going to call the adjacent side, or A. The side opposite, we're going to call O, and then the longest side is the hypotenuse, which we're going to call H. So, does anyone remember how to remember the ratios of sine, cosine, and tangent?
SOHCAHTOA.
SOHCAHTOA. So, SOHCAHTOA means that the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. Now, some people will memorize the other 3 as well, but what I do is I just memorize the reciprocal functions. So sine and cosecant are reciprocal. So once I have the sine, I just flip it and say because the cosecant, you just flip that. And so I just remember, I don't really memorize it as hypotenuse over opposite. I just remember it's the reciprocal of the sine. And the secant is the reciprocal of the cosine, and the tangent and the cotangent are reciprocals as well. All right, so now, once we have the 3, if we have two of the lengths of a triangle, then we can solve it. We can find the trig functions, we can find the third side. So this is an example of the 30, 60, 90 triangle, which is one of the big triangles that you learn in geometry. So 30 degrees, that's the same as pi 6. And so this would be 60 degrees and 90. And so then the ratios of a 30, 60, 90 triangle are 1 to radical 3. Now, if you don't have a 30, 60, 90 triangle, but you're trying to find the third side, you use the Pythagorean theorem. But then once you have all three sides, then you can use the trig functions. You can write the trig functions for the angle. So you would say then that the sine of theta here, the sine is the opposite over the hypotenuse, so radical 3 over 2. So that means the cosecant, you flip that. So it'd be 2 over radical 3. The cosine is adjacent over hypotenuse, so 1 over 2. So then the secant would be 2 over 1. The tangent is opposite over adjacent, so radical 3 over 1. So the cotangent, you flip it, 1 over radical 3. Okay, any questions? Okay, so here's the triangle. So I would like you to find the 6 trig functions for angle theta. All right, so Junior, what's the length of the third side?
5.
5. Okay, so it's a 3, 4, 5 triangle, or you could use the Pythagorean theorem. 3 squared plus 4 squared is c squared, and then solve. So you get 5. All right, Hannah W., what is the sine of theta?
4 over 5.
4 over 5. And so then what's the cosecant?
5 over 4.
5 over 4. All right, so Skylar, what is the cosine of theta?
3 over 5.
And then what's the secant?
5 over 3.
Excellent. All right, Denon. What's the tangent of theta?
4 over 3.
And then, so what's the cotangent?
3 over 4.
Excellent. All right, any questions on any of those? Okay, another triangle that that you need to know are the 45, 45, 90 triangle. And so that is 45, 45, and then you have the ratios are 1, 1, radical 2. And so in 45 degrees is pi fourths in radians. So it's pi fourths, pi fourths, pi halves. Okay, so that's another a special triangle that you deal with in geometry. Okay. All right, so before evaluating a trig function, you need to determine whether you have a special triangle. Okay. And then if you do, then that can help you and then you won't have to use a calculator if it's one of those special triangles. Okay, so for example, if you have the tangent of pi fourths, well, pi fourths is 45 degrees. So if you think of your 45, 45, 90 triangle, 1, 1, radical 2, then the tangent is just going to be 1 over 1, so it would be 1. Okay, so now see if you can do secant of pi fourths without using your calculator. All right, Chloe. What do you think about the secant of pi fourths?
Is it the square root of 2?
Yeah, because the cosine is adjacent over hypotenuse, so 1 over radical 2. So then the secant would be, you just flip that, radical 2 over 1, or just radical 2. Okay, good. Okay, so now, before using a calculator, you need to know whether the angle is in degrees or radians. That is the most common mistake on tests with students, especially if you're going back and forth. You got to make sure before you start putting stuff in the calculator that you're in the right mode. Okay. So now radians. It could be if it could be written radians or rad or the little r, like almost like an exponent, or if there are no units at all, then it's assumed to be radians. Okay, so if it says you have an angle of 2, it's not 2 degrees, it's 2 radians. Because if it's degrees, they have to have the degree symbol up there. Okay, so here, if we want to evaluate the sine of 56.4 degrees, then you put that in your calculator. You make sure that you're in in degree mode. Okay, so let's just do that real quick. Oops, golly, got a lot of windows open here. So you press the mode button on your calculator. There we go. And so you press the mode button right there, and then you go down and arrow into degrees. Okay? All right, then if we want the sine of 56.4 degrees, if we're already in degree mode, we don't have to worry about putting the degree symbol on there. You can just do the sine of 56.4 and then press enter and boom. Okay? All right, so let's have you do evaluate the cotangent of 5 pi 11ths. Now, do you remember how to do that if there's no cotangent button? So how do you do cotangent if there's no cotangent button?
You just do 1 over tangent.
Yes. So you'll do 1 divided by the tangent of 5 pi 11ths. All right, so Skylar, when you've got it.
.144.
0.144. Where is it? I guess it's nowhere. 0.144. Excellent. Okay, any questions on that one? So again, you got to make sure you're in the right mode. And then 1 divided by the tangent will get you the cotangent. Okay, now, as you flip over, we're going to do the applications and talk about the graphs. But I want you to see on the back there, there's a place for the 2 special triangles, 30, 60, 90, 45, 45, 90, and then a bunch of formulas, okay? So what I would like you to do is to actually start filling these out. You don't have to have them done by Tuesday or whatever, but just start filling those out, and we'll go through and make sure you have everything, as well as the unit circle on the next page. This is the only page where we have, the only guided notes where it's 3 pages because of the unit circle. But anyway, we're going to stop there. And so remember, no class on Monday. You guys have a great weekend. Thanks for working hard today. I appreciate it. And we'll see you Tuesday. So see you later.
Bye.
Thank you.